Computer science is one of the most valuable degrees you can get as an undergraduate student. Today we'll talk about what it's like to be a computer science student in college. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
All right, Dave, let's dive into what it's like to be an undergraduate student studying computer science. First, can you give us a general overview of what a curriculum for computer science would be like?
A computer science curriculum is going to include some math courses. It's going to usually include some courses in the natural sciences. And of course, most of the courses are going to be computer science courses. And computer science courses range from programming courses to more theoretical courses to more project-based courses to all of the many subdisciplines within computer science, like artificial intelligence, computer graphics. There's so many different subdisciplines. Computer science is a really big field. And so you have a lot of options usually and a lot of different directions you can go. Curriculums are going to differ from institution to institution. Each university is, of course, trying to distinguish itself, attract students who have a lot of different options to their particular program. Some programs tend to be more theoretical, and some programs tend to be more applied. The more theoretical programs are going to have maybe more math courses, more theory courses, a little less of a focus on software development. The more applied programs are really preparing you more to be a software developer, which is what the vast majority of people do, by the way, with a computer science degree. The vast majority of people who get a computer science degree go on to be software developers. A small portion will go on to graduate school, and then many go on to tangentially related fields like cybersecurity or like game programming that might not be as CS theory heavy.
So if someone's thinking that they want to study computer science in college, how do they know whether to go towards a theory-focused program or a more applied-focused program?
It really has to do with what interests you. So do you know 100% you want to be a software developer, sometimes called a software engineer, after you graduate? If you do, you might want to go into a program that's specifically in software engineering, or you might want to go into a computer science program that has more of an applied focus. Are you not so sure, or are you maybe interested in going to graduate school and doing research? Are you more interested in the underpinnings and kind of how we just solve problems using computational tools? Are you more interested in computer science itself rather than what you can do with computer science, what software you can build with computer science? Then you might be more interested in more of a theory-oriented program. And you will get a sense of this by looking at the curriculum of the particular program that you're interested in. So some programs, when you're exploring them, you'll see they have more math classes than other programs. You'll see they have more theory of computation courses. They have data structures and algorithms might not be one semester, it might be 2 semesters. One semester called data structures, one semester called algorithms. The more you see a focus on theory-oriented courses, the more you see a focus on the mathematical aspects of computer science, the more likely that's more of a theory-focused institution.
What's the general track of a computer science curriculum?
So generally in the first year, you're going to start out with some basic math courses, and you also will probably take some introductory programming courses. That might be 2 semesters. So you might take a course called like Introduction to Programming and another course called Advanced Programming or something like that. In your second year, that's when you'll generally get into data structures and algorithms courses. And like I mentioned before, those might be 2 semesters, or at some institutions, they're combined into a single course called something like data structures and algorithms. And that's where you're really getting into how do we use computational tools to solve problems. When I have a particular problem, how do I know for the right data structure or algorithm to reach for? That course is going to give you that tool set and help you be able to analyze code using things like big O notation to understand its theoretical performance implications. So you're really going to start to understand the science of computer science, hopefully in that second year, and also what the computational problem-solving aspect of computer science is all about. Then, as you get into the third year and the fourth year, you're going to take more advanced programming courses. You might take some heavier theory courses like theory of computation. You might also start taking some courses that might go into what's called a concentration or a specialization into some of the subdisciplines of computer science, things like artificial intelligence or computer graphics or game programming or cybersecurity. These are sometimes advanced electives or concentrations within a computer science degree. And you also will probably take some more hardcore what are called systems courses. These are things like operating system development or computer architecture that give you a sense of how things work at a lower level within a computing system and how we kind of build up the software stack. What are the different levels of the software stack that we use for solving different kinds of problems and how do they all fit together? So typically, by the time you get to your fourth year, you'll be doing some kind of culminating experience. And that might be an undergraduate thesis that goes on for a year. That might be a capstone project. That might also just be some kind of very advanced electives that include some large project components. A lot of these courses that I've been talking about will include a lot of individual work, but there also usually is group work as well. Because, of course, when you work at a corporation after you graduate, you're going to be working on a team. Even if you just do open source work, you're going to be working on a team with other programmers. And what a lot of people are surprised by is that there actually is a significant communication aspect to being a programmer, to working in computer science. There definitely is the ability to program, be able to solve logic problems, be able to wire together APIs, be able to think about how we solve some interesting problem using computational tools. But there's also this aspect of how do you communicate those ideas to others. And there might even be a writing course involved. There might be a course about how do you handle documentation, how do you write great documentation. You might take a course on human-computer interaction, which is about how do we interact with computational machinery. What's the interface between the computer and the human? Where does the human end and the computer begin? How does a computer respond to the wants and needs of its user? How does the user get feedback back from a program? So there's actually a significant communication aspect to a lot of working with software. So in summary, you're going to take some theory courses, you're going to take some math courses, you'll probably take a lot of programming courses, you're going to take some courses that help you understand how all the different levels of the software stack fit together, you're going to take some courses within some of the subdisciplines like artificial intelligence or game programming or cybersecurity, and you're probably going to do some project-based courses where you build some larger pieces of software.
Typically, what languages or how many programming languages does a computer science student learn?
Any good program is going to have one language that you learn well. So one general purpose language, maybe it's Java, maybe it's Python, maybe it's C++, that you spend at least a few courses in. You really start to become an expert in. You really start to have some chops in so you can really build things that you can imagine. Then you're going to branch out. You're probably going to take a computer architecture course where you learn some assembly language. You're probably at some point going to take some course where you learn to do some web development and you're going to learn some JavaScript. You're probably going to take a course in mobile development if it interests you, and that might be in Swift or Kotlin or one of the modern mobile languages. You're probably going to end up getting exposure to many different kinds of languages. And there's usually also some kind of programming language theory course where you understand the fundamental underpinnings of programming languages, how programming languages are built, how their type systems work, how people who actually design languages design them. That will probably expose you to some interesting, more academic languages and also some other paradigms beyond what you learned in the earlier introduction to programming courses, such as functional programming or logic-oriented programming. So you're going to get good at one particular general purpose language usually, and then you're also going to get exposure to a wide range of other languages for particular purposes.
What does it take, or what tips do you have to be a successful computer science student?
So we covered some of this in a previous episode we did called Learning to Code, which I'll put a link to in the show notes. And a lot of the things that are just generally useful when you're learning to code are also useful when you're becoming a computer science student. But I'll tell you just one really broad thing about college that a lot of people don't always realize when they're entering college, which is that a lot of being successful in college has to do with time management. So people think when people fail out of college that it's, they couldn't cut it intellectually. That's almost never the case. When somebody doesn't do well in college, it's almost always they were capable of actually doing the coursework, but they weren't able to manage their time well. In computer science, you do generally do a lot of independent projects. There'll usually be some group work and some experiential learning too, but there's going to be a lot of times where it's just you and your computer, and you need to build a program up to some kind of specification. And you need to be able to manage your time well, because usually these projects are not just half-hour projects. They're not 1 hour writing a couple-page essay. They're multi-hour projects done over multiple weeks. And it might end up that you spend, 10 to 20 hours on one of these projects. And so being able to keep yourself motivated, being able to use the time effectively, being able to start early so that you can ask the instructor or a teaching assistant questions when you need to are really critical skills. And so I can't stress enough how being a computer science student requires good time management skills. In our earlier Learning to Code episode, I talked about some general things. A lot of a computer science degree involves programming that makes somebody a good programmer. One of them is being a perfectionist. You really need to worry about the details. If you have even one character wrong in a program, it can mean something different than you intend. You need to be somebody who, when there's an error, you're willing to keep digging into it till you get to that little thing that's causing you that error. You need to be somebody who's a little bit tenacious about searching down the cause of problems and fixing those problems. So you need to be a little bit of a perfectionist. You also need to be somebody who is willing to fail, because you're going to all the time run into errors. That all software has bugs, all software has problems. It's very unlikely that the first time you build something, it's going to just work perfectly. And you're going to end up having a lot of failure. Sometimes you're going to need help, maybe from your instructor. Sometimes you're going to just need to keep at it. And being okay with failure and being able to ask for help. Frankly, today, there's a lot of great resources online. So being somebody who's okay with needing that extra help sometimes and seeking it out is a very helpful personality trait to have. But being okay with the fact that, and not getting overly frustrated by the fact that your programs, the first time you write them, probably will not be right, and you'll need to just overcome those hurdles. And this goes without saying almost, but you need to be somebody who actually enjoys solving logic problems, doing problem solving. A lot of computer science is problem solving. You need to have some kind of mathematical inclination. Doesn't mean you have to be a math superstar, but you need to be able to do math up to the college level in order to be successful as a computer science student. So you have to have some kind of mathematical ability. It doesn't mean you need to be an amazing math student, but you need to be a reasonable math student. So yeah, perfectionism, willingness to fail, and ability to ask for help, and possessing some basic math skills are pretty much the prerequisites for being successful, in my opinion.
So where do you go with a computer science degree?
The vast majority of people who get a computer science degree end up going on to be software developers, sometimes called software engineers. You can get a degree specifically in software engineering, like I mentioned earlier, but just the majority of people who get just computer science degrees end up being software engineers. So that's what the vast majority do. However, some people will go on to graduate school, and some people will go on to kind of a tangentially related field like information technology. By the way, we did a previous episode that I'll put a link to in the show notes on what's the difference between computer science and information technology or cybersecurity. And some people will go into something totally different than computer science after they graduate, but that's actually more rare in computer science than it is in a lot of other fields. The reason is people with computer science skills are in very high demand. This is a very, very lucrative field right now in the United States, at least, to be going into. There's more demand for software developers, software engineers, than there is supply. Therefore, salaries are high, and the vast majority of people who graduate with a degree end up finding a job within the field. So we're very fortunate to be working in a field that's very much in high demand.
So you touched on this a little bit, but outside of computer science, what are some important classes that you're going to be taking?
Yeah, I mentioned you're going to take math courses. You're probably for sure going to take a class called discrete math, which is about non-continuous functions, usually some set theory, some graph theory. If you don't know what any of those are, usually that course is kind of apart from the rest of the math curriculum in that it's not necessarily similar to the other college level math courses that you'll take. So discrete math is usually taught with the computer science department in mind. Sometimes it's even taught out of the computer science department. You'll also generally take the first level of calculus, and then some programs will have you also take linear algebra. They might have you take an introductory statistics class. Some will have you take a numerical methods class. So you might go quite a bit further depending on the program that you choose, but at a minimum, you're at least usually going to do discrete math and the first level of calculus. You'll also generally have a requirement to take some kind of hard sciences class. So maybe that's a course in physics or chemistry or biology. The reason being that there is a science aspect to computer science. There's the scientific method. And getting a class that gives you a more general introduction to the scientific method is generally considered a good thing. So a lot of programs will require you to take some science class in the natural sciences to reinforce the kind of science worldview that you might have if you end up going into research in computer science.
Then, of course, there'll be the general education requirements that are part of a bachelor's degree.
Right. Of course, any institution you go to pretty much will have general education courses that you're taking every semester alongside your computer science courses. Some people call that the liberal arts core at their institution, and some just call that general ed.
What should you look for if you're thinking about applying to a computer science program?
Yeah, there's a few things I think you should look for. The first thing is, what is your desire after you graduate? Is your desire to be a software developer? Are you sure about that? If you are, then you might be leaning more towards one of these more applied institutions. So look at their curriculums, see how heavy they are on programming classes versus more theory/math courses. Another thing you want to look at, of course, is the faculty. So are the faculty people with industry experience? If you want to go more towards the applied side, that might be helpful. However, if you're more interested in the research and the theory side, then you want to look at, are these people who have significant research experience, and do they have significant research accomplishments that they really are bringing the best and most interesting cutting edge topics into the classroom for you? So it depends, again, what are you more interested in doing later on? If you're interested in working in industry, then maybe you want to go to more of an industry-focused school with more industry-focused faculty. If you're interested in going on to graduate school, or you're interested in working more on the research side, then maybe you want to go to a school with more research-oriented faculty. Another thing is, how much individual attention are you going to get? Now, this might have to do with who actually teaches the classes. If you go to a large state research university, a lot of your courses, you might be surprised, are actually taught by graduate students or teaching assistants or adjuncts, and not actually by full-time faculty. So this is something to definitely consider, because you might not actually be getting to experience those faculty that are getting a lot of the highlights from the program. So that might be a decision between going to more of a small teaching college versus going to a large research institution. So you want to look at the faculty and who's actually teaching the courses. Another thing you might want to consider is, of course, the ranking of the program. Now, this is not the only thing. Some people get overly caught up in rankings, but it is something to consider. Generally, where you go to undergrad in terms of ranking might help where you end up with in grad school in terms of ranking. It's not the only thing, of course, that grad schools are looking at, but it doesn't hurt. So it's something to look at, but it's definitely not something I would make a decision based on, solely at least. And then lastly, I would, of course, consider all just the usual things about college. Like, is it a place you're going to have fun? Is it a place that's in a location you want to be? Is it a place that's reasonably priced? All the general things still matter here. I will say that if you're successful in a computer science program, you're probably going to get a job that pays well. And so this is something to think about as well, is that, okay, getting into a job that pays well, maybe I'm okay with a slightly more expensive program that gets me there. But this is a trade-off that you have to make on an individual basis based on your family resources and what kind of scholarships are available, et cetera, et cetera.
As a computer science student, are you doing a lot of work with others, or is it mostly individual in your classes?
There's a combination of both, but the truth is that, there's a lot of individual work. If you're an extremely social person, then maybe you will not like some significant portions of the computer science degree. There's going to be project-based work where you work in teams in most programs, however, there's going to be a lot of individual work in any program. So if you're an extremely social person, this might not be a degree you love. On the other hand, if you're more of an introvert, a lot of people who are more of introverts tend to get kind of drawn to computer science. But there will still be courses where you need to communicate well, as we talked about earlier. So you will be taken out of your comfort zone at points. You'll have to do presentations. You'll have to write essays, just like in any other kind of college discipline. You'll have to work on small teams. So you need to be comfortable with it. But if you're more on the introvert side, you might actually enjoy this degree more than most other degrees.
If you're interested in cybersecurity or game programming, would you still study computer science?
Yeah, so the interesting thing is that at some institutions, those are their own degrees. So there's like a degree in cybersecurity. And at some institutions, those are concentrations or just advanced electives within computer science. So it just depends which program you choose. But at some programs, if you want to study cybersecurity, you'll actually be a computer science student who takes a couple of your more advanced courses, or maybe even 4 or 5 advanced courses during your junior and senior years in cybersecurity. And at some institutions, you'll do a degree from the beginning called cybersecurity that might be wholly focused on it for the entire 4 years. So this is something to really look out for. I think if you know at 17 or 18 years old that you want to go into a particular subdiscipline, which is not everything that everybody knows, but if you do, then you might want to look at a program that is specifically in that subdiscipline. I'll give you some other examples. You mentioned game programming. Sure. A lot of places, they'll have a computer science degree and they'll just have a couple advanced electives in game programming. At some schools, there's a whole degree, all 4 years, in game programming, where you're still going to take computer science courses with other computer science students, but you're going to start taking game programming specific courses as early as the first year. Other examples of this are things like data science. Again, sometimes people with CS degrees end up working in data science, but there's also places where you can get a whole degree in data science, or things like digital forensics, or things like software engineering, which sometimes, again, you have a whole degree called software engineering, and sometimes you do a computer science degree and you take some courses in software engineering during your junior and senior year. So if you know 100% what you want to do when you graduate from college, like the exact type of profession when you're 17 or 18, then maybe it makes more sense to go into one of these very specialized degrees. However, if you want to kind of keep your options open and just know you want to work in a computer science related field, then it makes more sense to do the general degree and then figure things out and take some specialist classes as you get towards the end. All right, well, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you next week.
Bye.